Okay, for question number 7, we've got an object in simple harmonic motion, and we're going to be looking at what happens if we change one thing. So we're going to change the frequency. In question 7, the frequency is going to become twice as large. So we've got twice the frequency, but the amplitude is staying the same. So the amplitude does not change in this question, and we're asked which of these 4 things is also doubled. Is it going to be the time period, which is t? Is it going to be the total energy, which is E subscript t? Is it going to be the maximum velocity, which we can go with Vmax? Kind of hard to do subscripts with this chunky pen. And the final one, the maximum acceleration, which is Amax. One of these 4 things we are told has doubled, so we've got to work out which one it is. And again, you can go down the process of elimination route. If we do the consideration of it algebraically, though, we should be able to find fairly easily which one of these is also going to double. So the first thing we notice, if we've got a frequency of 2f, I'm just about to see that, yeah. Frequency has gone to 2f, so double the frequency. We know the time period, I'll just write it up here. Time period is 1 over frequency. So if this becomes twice as big, then the time period is going to be half what it used to be. It's going to take half the time to do each oscillation. So the time period is not going to double, it's going to half. That's not going to be our answer. What else do we have? Well, the energy is our next one, the total energy. You'll be remembering that your object is basically oscillating like this, backwards, forwards, backwards, forwards. If it's oscillating twice as fast, but it's not increasing its amplitude, we're still going to get to the point, the same point as it was before, the very, very top of the swing, where its kinetic energy is back to 0. And its potential energy at that point is the only energy it has. So if we take that point at the top of the swing, the potential energy is the same as the total energy because there is no kinetic. Well, how big is that potential energy going to be? That comes from the size of the swing. We're told the size of the swing hasn't changed. So even though we've doubled the frequency, the energy will not be any different at the point there compared to what it was before. And if that's the case, total energy never changes throughout the swing, remember, we're going to find that the total energy hasn't changed from the first kind of pendulum to the second kind of pendulum. So this thing here is halved, this thing here is going to be exactly the same. Our answer has got to be either Vmax or Amax. Well, if we get the equation for acceleration, we find the maximum acceleration, Amax. That's going to give us an equation of 2 pi f all squared a. 2 pi f all squared a. Now the a hasn't changed, but the frequency, as we said, is doubled. If I double something in this bracket, because it's squared, that's going to end up with being a factor of 4 greater. So if the frequency is doubled, the maximum acceleration is going to be 4 times as much. So the answer must be Vmax, and we can see that from the equation that we're given for Vmax as well. Just to make that really clear, the maximum velocity is going to be given as 2 pi f a. Because it's kind of 2 pi fx usually, and your maximum comes from that. So if we, where are we? Yeah, so when we've got our equation like this, obviously if we double this, then this is going to double, and therefore you've got your answer for question number 7. It's going to be Vmax, which is going to be answer C.